Okay, the test review. Remember, test is on Wednesday. So, again, remember also that there is another review online for 2-1 through 2-4 from the quiz. So there's extra practice and review there if need be. So this is a square root. The number's not there, but it is square root. So when we're using our piece of paper, our slip, we're going to use the x squared line, the x squared row. That's it. We're going to look for any number less than 96 that goes into 96 evenly. And that would be 16, square root of 16, and the square root of 6. Okay, so the square root of 16 then becomes 4, and the radical 6 just comes down. On number 2, you're looking at the cubic line, the 3 line. And you'll find out that numbers that go into that are the cube root of 27 and the cube root of 12. This is going to simplify just down to 3. 3 times 3 times 3 is 27. And then the cube root of 12 just hangs along. 3. 72 is going to simplify to radical 36 times radical 2, which is going to simplify to 6 radical 2. But remember, you have this 2 out here. So that's going to give us a 12 on the outside. We know we have a radical 2 stuck on the inside right there. But we can't forget our x's. We have x to the first, but we have to deal with this. Remember, this is the 2. So how many times does 2 go into 5? 2 times. Since we already had 1, and now we're getting 2 more out, that's x to the 3. And how many left inside? 1. Because 2 times 2 is 4, plus 1 is 5. And that's our answer. Okay, 125 is a perfect cube. Cube root of it is 5. So this is going to come out 5 times 4, which is 20. And then x to the 6 divided by 3 is 2, and that is it. Okay, 3 and 4, exact value. Remember, this does not mean a decimal. This does not mean use your calculator. Simplify and leave in radical form. That's exact. A calculator is an approximation. It's a rounded number usually. And leave no radicals in denominators. So, again, you cannot add 128, 72, and 48. That would be like saying x plus y plus z is x, y, z. You can't do that. It's just x, y, z. But in this case, we can simplify. And we can break each of these down. So 128 is 64 and 2. 72 is 36 and 2. And 48 is 16 and 3. Square root of 64 is 8. Radical 2 stays. Square root of 36 is 6. We're adding these. Radical 2 stays. Square root of 16 is 4. We're adding these. 4. Radical 3 stays. Join these together, and we get 14 radical 2 plus 4 radical 3. Okay, this one's a little bit nastier. Okay. We have this radical here minus this radical here minus this radical here. So, 125x to the 4th. Well, if you look up a little bit, we had 125x to the 6th. So this could be kind of similar. Cube root of 125 is 5, so 5 is going to come out. We already had x cubed, but we're going to be able to add one more x because there's 4 of them here. So that's going to be 5x to the 4th. And then on the inside, we're just going to have that lonely x to the 1st. Oh, silly, silly me. That's not x cubed, that's the cube root. So, we're going to be able to get one x out. Sorry, I wasn't paying attention. Kind of cramped in there. I was trying to call attention to it, and I'm ignoring myself. So, 5x on the outside. outside squared. Because we had 1 here, this was x to the 1, we brought another 1 out. And then the cube root of x on the inside. Sorry. Then minus the cube root of 8 is 2. The x squared is going to be there. And what's left on the inside? Just that lonely old x. And then the last one, 135. That's going to break down 27 times 5. Cube root, obviously. Cube root of 27 is 3, so we're going to subtract 3. And 6 divided by 3 is 2, so x squared. And what's left on the inside? Radical 5. Well, notice these are the same. So I do 5x squared minus 2x squared, which gives me 3x squared times the cube root of x minus 3x squared times the square cube root of 5. Don't leave those little indices off. 7. First thing we do, multiply. It's the cube root of 288. That breaks down, we use our chart, and we're going to get cube root of 8 times the cube root of 36. Cube root of 8 is 2 times the cube root of 36. On number 8, any, outy. 4 times 2 on the outside is 8. On the inside we have 6 times 8 and x times x. 48 is going to break down square root of 16, square root of 3. Don't forget about this 8 because this is going to become a 4. So 8 times 4 is 32. Square root of x squared is x. Everything comes out. What's left on the inside? Radical 3. Number 9. First off, we write this like so. I'm going to go one step further and say the square root of 9 is 3 over radical 2. And you could have gone right here immediately if you wanted. That's fine. But now I got to get rid of the radical 2 on the bottom. So I multiply by radical 2 over itself. On the top, I'm going to get 3 radical 2 over 2. And that's it. I cannot go any further. Same idea here, except this time I cannot just multiply by radical 5. I need to multiply by 1 plus radical 5. Top and bottom. Treat this like it's parentheses and distribute. 4 plus 4 radical 5. On the bottom, I just do first and last. 1 times 1 minus, plus minus times minus, 5. Which gives me negative 4. Which can simplify. Because I can rewrite this as 4 over negative 4 plus 4 root 5 over negative 4. And now that will break down to negative 1 minus 4 radical 5. That's it. 2.5. Now this is post quiz 1. Simplify each into exact value, which means no decimals. Again, we're just straight multiplying. 9 times 18 is the 4th root of 162. X to the 1, X to the 12 is X to the 13, and Y to the 6th. Now, 162, we look on the fourth line. Remember, pay attention, fourth line. This is 81 and 2. Fourth root of both. So the 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So this simplifies to just 3. My x's. 4 goes into 13 3 times. What's left on the inside? Well, that's 2, obviously, right there. 3, well, again, 4 goes into 13 3 times. That's 12. Plus 1 is 13. 4 goes into 6 1 time with 2 left over. And there you have it. 3. Double check here. Yeah, 4 goes into 13 12 times. That's 3x cubed y times square root of the fourth root, sorry, don't forget the index number like I just did. Fourth root of 2x y squared. Okay, number 12. We cannot add these. Okay? This would be like trying to add 2x plus 4y. Can't do it. But we can break it down and see what happens next. Fourth root of 32. 16 and 2. Don't forget about this 2 right here. So the fourth root of 16 is 2. But we already had a 2 out there, so that's going to make it 4. Our x's. 4 goes into 5 1 time with 1 left over. This 2 is still in there. So it's 4x times the fourth root of 2x. Plus, let's see what happens here. 162 is going to be 81 and 2. Fourth root on both. The fourth root of 81 is 3. So that's going to be on the outside. We have an x out there. The x on the inside has to stay. So this 2 is on the inside, the x is on the inside. Now we have the same radical, fourth root of 2x. So now we just add 4x plus 3x, and we get 7x times the fourth root of 2x. Oh, I lost the page. There we go. Okay. Okay, so now we have to rationalize this cube root of 4x. But remember, now we can't just multiply by square root of 4x, so this is cube root. So we got to think about coming out in groups of 3. And remember, 4 is equal to 2 times 2, which means we need a third 2. Okay? That will give us 8, which we'll reduce. I also need 2 x's to give me my third. So I have 1 here, I need 2 more. So I'm going to multiply by the cube root of 2x squared. Because then, underneath, I will end up with this. 2 times 2 times 2 times x times x times x. Drawn out. Or simply cube root of 8x cubed, which will then simplify. So on the top, what do I get? I get 2 times the cube root of 2x squared over, what I just wrote here, the cube root of 8x cubed. And remember, this simplifies to 2x. And then, one step further simplifying, this 2 cancels with that 2. So what I'm left with is just the cube root of 2x squared over x. Okay, 2.6. Rewrite in rational form, exponent form. Well, remember, this is our denominator, so it's going to be x to the 2/3. And remember, most of us know that the square root of x, which has 1 and 2 there, is x to the 1/2. So use that as your point of reference. If you ever forget, I do. I forget sometimes. I get confused. So therefore, I go back to what I know and then extrapolate from there. So remember, this is 2. So that's 7 to the 5/2. But remember, this is the same as this. Just two different ways of writing it. Here's the 1. I saw some people in class do this, 7x to the 1/5. That is incorrect. This 1/5 is only attached to the x right now. And yet the 7 is also inside. So we need to put this in parentheses. Okay, now we're going the other direction. 2x is going to be underneath my radical. The 4 is here. And the 3 is here. I could also put the 3 underneath the radical. I would just make sure I put the 2x in parentheses. Otherwise, the 3 would only be with the x. Okay, -5 to the 1/3. That does not have anything to do with going on the bottom. The negative does not have anything to do with going on the bottom because it's just the number. So that is just the cube root of -5. If the exponent was negative, that's when we talk about the inverse. Okay, this one is kind of like what I was talking about in number 16. The x is the only thing that goes under the radical. And remember, our denominator is our index number. And the 8 is on the outside. This is 8 times x to the 2/3. Okay, evaluate to an exact value. Number 20. First off, there's two ways to go about it, but if you just look at the cube root of 8, that's 2. And if we square that, that's 4. The hard way is to take, it's not really hard, we could say 8 squared, because remember, this could be written this way. And we could say 8 squared is 64. And that's still going to lead us to 4. So it just depends on how your brain processes it. Either way, we get the same answer. Okay, 4th root of 256 over the 4th root of 625. Well, those are perfect 4th roots, so that just simplifies down to 4 over 5. 4 times 4 times 4 times 4 is 256. 5 times 5 times 5 times 5 is 625. And here we are, last 2. -27 to the 2/3. Again, -27 is under the radical. My denominator is here, and 2 is here. Now, if I write it that way, I need to square -27. So I need to do 27 times 27. Because negative times negative is positive. And that's 729, which I should have known. So I would get the cube root of positive 729. And then look at our chart, the cube root of 729 is simply 9. The other way to go about it is to write it this way. And the cube root of -27 is -3. But then that number squared still leads you to 9. And over here we have basically 81 to the 1/2 over 25 to the 1/2, which is just the square root of both. And therefore that is just 9 over 5. 11.7. Just a reminder, some basic rules. X to the second times x to the fourth is x to the sixth. X to the sixth divided by x to the 2 is x to the fourth. Here we keep the base and add the exponents. Here we subtract the exponents. And here we're going to multiply them. X to the 12. So here we actually have three things. We have the 9, the x, and the y. And the 3 halves is going to get sent to each of those. Because this really has a 1 there. So we're going to get 9 to the 3 halves. X, we're going to have the 2/3 times the 3 halves, which, think about it, reciprocals cancel. And then we're going to have y to the 4, which is 4 over 1 times 3 halves. So you can do 4 times 3 divided by 2, or just cancel. Either way, you get 6. So 9 to the 3 halves, remember, two ways to think about this. You can cube 9 and then take the square root, or you can take the square root and cube that. Well, I'm going to take the square root of 9, which is 3, and cube that and get 27. That's the quickest way there. Then, again, remember the x just was x to the 1, and we end up with y to the 6th. And that's it. Here, at first, we're going to add the exponents on the top. But we need to find a common denominator, which is going to be 6. So it's going to be 2 times 3, so 1 times 3. 3 times 2, 2 times 2. That's going to be 7/6 on top. Over x to the 1/4. Well, we need to subtract that. That's going to be 7/6 minus 1/4. Common denominator 12. 6 times 2, 7 times 2. 4 times 3, 1 times 3. That's 11/12. So 7/6 minus 1/4 is x to the 11/12. On top, we keep the base and add the exponents. For divide, we subtract the exponents. Okay, number 26. Audi times Audi. Correct? No. Why? Because this is a 2. We cannot do that squared and cubed. So we have to rewrite this as 3x to the 1/2 times 4x to the 1/3. Keep the base and add the exponent. So over here, 1/2 plus 1/3, common denominator. 2 times 3, 1 times 3. 3 times 2, 1 times 2. That's 5/6. So 3 times 4 is 12. And keep the base, add the exponents with common denominators. 5/6. Okay, first we're going to rewrite this as x to the 1/2 over x to the 3/4. Then we're going to send the 2 in here and there. Well, 1/2 times 2 is just 1. And 3/4 times 2 is 6/4, or 3 halves. Now, 1, you can think about 1 really being 2 over 2. Now, if you remember, I talked about this. There's two ways to do this. You can officially do the subtraction, do 2 halves minus 3 halves, and get x to the negative 1/2. But then we have to send that downstairs, get 1 over x to the 1/2. The other thing is to look and say, hey, I have 2 halves up top, 3 halves downstairs. Where do I have more? Downstairs. How many more? 1/2. Either way you think about it is fine. 28. Don't forget to check for extraneous solutions. So remember, first step is always get the radical by itself. So we're going to minus 7 on both sides. 3 radical x equals 15. Divide by 3. Can't do anything until it's by itself. Don't take it out until it's by itself. Now, we want to get rid of square root by squaring both sides. X equals 25. We did the 25 back in here. Square root of 25 is 5. Times 3, 15 plus 7, check. Minus 9, both sides. Cancel. Cube root, don't forget that. Very important. Plus 7 equals negative 4. We're going to cube both sides. Cancel that. X plus 7 equals negative 64. Minus 7 on both sides. We get negative 71. Take it, plug it back in. Negative 71 plus 7 is negative 64. Cube root of 64 is 4. Cube root of negative 64 is negative 4. And negative 4 plus 9 is 5. Check. It works out. Very simple here. We're just going to cube both sides. Which gives us 2x plus 11 equals 4x minus 13. Going to subtract 2x from both sides. In fact, I'm just going to add 13 to both sides right now. 24 equals 2x. Divide by 2, x is 12. Plug it back in both places. 2 times 12 is 24. Plus 11 is 36. So we get the cube root of 36. Equal to 48. 12 times 4 is 48. Oh, hold on. Sorry. 2 times 12 is 24 plus 11 is 35. So cube root of 35. Over here, 4 times 12 is 48, minus 13 is also 35. We don't have to evaluate that. That's a true statement, so 12 works out. Radicals by itself, so we square. That gives us x plus 20 equals x squared. We're going to move these both over by subtraction, which gives us x squared minus x minus 20 equals 0. We need to factor both sides. I mean both the left side. X times x. We need two numbers that give us 20 that differ by 1. That's going to be 5 and 4. We want leftover negatives, so there you go. We set them both equal to 0. And we solve. X is 5, x is negative 4. Now we plug those in. 5 plus 20 is 25, and the square root of 5 is 5. So 5 on both sides works. 20 minus 4 is 16, the square root is 4. But 4 is not equal to negative 4. So therefore, this is not a solution. It's extraneous. So 5 is the only correct answer. And the last section, 2.9, last 3 of the review. Again, don't forget to check. So this is the same thing. We just need to take one extra step. So minus 7 both sides. And that gives us 2. And we rewrite this. Or we don't have to. X to the 1/3 equals 8. Divide by 2. X to the 1/3 equals 4. Now, there's two ways to think about this. We can look at it this way or this way. In this case, what will we do? We cube both sides, which would give us x equals 64. Well, again, here, if we want x by itself, with the property we know, 3 times 3 over 1, the reciprocal, times 1 over 3, it's the same process. It just looks different. We end up with x equals 64. We plug that back in, right there. The cube root of 64 is, obviously, 4. Times 2 is 8 plus 7 is 15. Check. It works out. Here, I'm going to rewrite this as 3x plus 12, fifth root, squared. Minus 11 equals negative 2. I'm going to add 11 to both sides. That gives us 9 equal to 3x plus 12 Now again, it doesn't matter which way we look at it. If we rewrite it like this, or if you want, you can keep it the way it is. Because then what you do is just multiply by the reciprocal. So that cancels, and that gives us 3x plus 12. And on this side, we end up with 9 to the 5 halves. Well, think about what that means. 9 to the 5 halves. Again, you can take 9 to the 5th power and then square root it, or you take the square root of 9, 3 to the 5th power, which is 243. Probably easier to do. Okay? Now at this point, we subtract 12 from both sides. Then we get 3x is equal to 231. And then divide by 3, and we get x is 77. We still have to plug that in, check it. 77 times 3 is 231. Add 12, we get 243. To the 2/5 power, 9 minus 11 is negative 2. It checks out. Okay, here, again, we just square both sides, that goes away. We get 11x plus 12 equals x squared. Move these over. X squared minus 11x minus 12 equals 0. Factor x and x. We need two numbers that make 12. 1 and 12, 2 and 6, 3 and 4. That differ by 11. 1 and 12. We want leftovers negative, so we make 12 negative, 1 positive. That's x plus 1 equals 0, and x minus 12 equals 0. Solve. Negative 1. X equals 12. Now we got to plug them in. If I plug in negative 1, I get 12 minus 11, which is 1. Square root of 1 is 1. So I end up with the statement 1 equals negative 1. Obviously not true, so this is extraneous. Let's try 12. 12 times 11 is 132, plus 12 is 144. Square root of that is 12, and 12 does equal 12, so we are good to go.